right, this is number 55 from section 3.7. Find the lines that are tangent normal to the curve of this thing at x equal 1. Support your answer graphically. So let's start. Remember that if we're doing a tangent line, for every tangent line, we need two things. We need a point, and we need a slope. Let's handle the point first. The x-coordinate of the point is going to be 1. The y-coordinate is going to be whatever we get when we plug 1 into 2 tangent of x times pi over 4. Now the last time I checked, tangent of pi over 4 is 1. So this is 1 times 2. My point is the point 1, 2. Are we all in agreement there? Okay. Now we're going to attack the slope part. Now to find the slope, I'm going to need to find that. I'm going to need to find that derivative. You got a constant multiplier of 2. The outside function looks like tangent. So let me take the derivative of the outside function, which is going to be secant squared. Let me leave the inside function the same. Oops. And then let me multiply that by the derivative of the inside function, which is pi over 4. Now, I don't need the expression for the derivative. What I need is the value of the derivative when x is equal to 1. So I need to find out what is y prime at 1, which is 2 times the secant squared of pi over 4 times pi over 4. Let's see. I think if I remember correctly, secant of pi over 4 is 2. Sorry, secant of pi over 4 is square root of 2. Square root of 2 squared that should make for an interesting video. There we go. We now resume our problem. Okay, so this thing, secant is square root of 2. Secant squared is going to be just plain old 2. So I get 2 times pi over 4. So I think my slope is just plain old pi. So my slope is pi. So that means my tangent line is going to be y equals 2 plus pi times x minus 1. And they also wanted to know what the normal line is, and that is y is equal to 2 minus 1 over pi times x minus 1, because the normal lines slopes are the inverse reciprocals of the tangent lines. Yes?
So what happened to the pi over 4 on the end?
This pi over 4 here?
Yes.
Well, I brought it down.
Yes.
Okay? And it's still right here, but I have these two 2's, and the 2 times 2 cancel with the 4, leaving me just the pi.
Because it was square, and it was pi. Yeah.
Well, again, just double check. Is it true that the secant of pi over 4 is equal to the square root of 2? I think that's right. My reference triangle looks like this: 1, 1, root 2. Here's pi over 4 angle, hypotenuse over 1. Yes, that's right. And then when I square that, I end up getting just plain. Yep, I think that's all right. Yes?
So why don't you bring the 2 by the secant down?
I did. This way. We're talking about this 2?
No, the one like by the secant squared. Why don't you bring that one down?
Okay. I need help. I'm not
You see the secant?
right here.
Yeah, and you see the square that's right above it right there. Why don't you bring it down?
Okay. So
Oh, that's why it's...
And then the square.
right.
Okay.
So secant of pi over 4 was the square root of 2.
Mm-hmm.
This square is really a square on all of that.
Mm-hmm.
So that squared the square root, and that ended up
That's
being
right
that
there.
2 right there.
Okay.
All right. So we good on that?
Yep.
Okay. It said support our answer graphically, and of course we would do that by document. Don't say that graph. What was this? 2 tangent of x times pi over 4. So there's our graph. And then what did we say one of the answers was? 2 plus pi times x minus 1. Does that look like a tangent line to you?
Yeah.
Does it look like it's going through the point 1, 2? Yeah. And then the other one was 2 minus 1 over pi times the quantity x minus 1. And does that look like the normal? Does that look like it's crossing the tangent line at a right angle?
Yeah.
Yeah. So I think we nailed that